Good morning, everyone, and welcome. It's a little early. It's a little late in the week. I'm glad you were all able to wake up for this. I'm Titus Winters. I'm the head of C++ libraries at Google. My team has been giving talks here. You've seen C++ libraries team. The kind of very brief overview of why I'm able to speak about these things. We have about 5,000 engineers that will make a change to our C++ codebase this week. Our C++ codebase is somewhere north of 100 million lines of code. And there are files in that codebase that are now applying for college. So we have some issues in scaling and thinking about how to manage all of this for the long term. So. Disclaimer, everything in here is based on my experiences over the last 4.5 years of trying to figure out how to make sure that this massive ship stays afloat and misses all of the icebergs. The comments and the suggestions in here are certainly not official Google company guidance because we're kind of making this up as we go along. But they are good suggestions and you should listen to me. And I will start with a very kind of abstract question, a sales pitch for the audience. And it is this. I am in possession of a tool. It is, of course, Clang-based, that if I sell this tool to you, you will have no worries about your C++ codebase in perpetuity. I will give you the following deal. If the audience pools all of their cash and gets me $5 million, I will sell you exclusive resale rights to this tool. Right? If this is working as advertised, I'm fairly confident that you can make your money back on this. Right? Who's interested? Some hands go up. Right? Nope, US dollars. Some hands go up, right? The hands that don't go up, is this because of the cost that I am advertising this for? Or is this because you don't believe that such a thing can exist? I want $5 million because I can live on a beach somewhere nice in perpetuity for that. I won't tell you which beach, because as I'm sure you've kind of started to think, to realize, right, such a tool can't possibly exist, right? There's not a silver bullet here. So if you come to the talk looking for one slide that answers your question, sorry, clearly not going to happen, right? First off, how would such a tool, what are you even measuring when you're talking about sustainability? And it's actually going to take me a few minutes to get to being able to define what I think is a reasonable definition for sustainability, so bear with me. Okay, the first thing, and I've mentioned this in a couple other talks, but the first thing that I really need you to think about is what is the expected lifespan of your code, right? Because that is not a given. That varies a lot depending on what sort of project you're working on. Right? The expected lifespan for code on a slide deck is, the weeks that you prepped that talk and then maybe you polish it up again if you run that talk again. Right? The expected lifespan of an academic project is the 3 weeks that you were assigned that task. Expected lifespan of a startup, you got an average of 2 years. Right? Most startups die, sorry to tell you. Right? The expected lifespan for Google's codebase, right? This is why I'm worried about things on the decades sort of time frame. Right? I don't think we're going anywhere. Then a secondary question, and it seems kind of a non sequitur at first, is this. Is your codebase per project or monolithic? Because this actually matters kind of quite a lot. And I'll have to have another brief aside here on the question of monolithic codebases. A monolithic codebase, that is one where all of the projects in your organization are checked into the same place, has some upsides. You get the upside of, if you're doing it right, the code base is largely consistent. Right? You can have policies and practices and things to try to get people to be using the same stuff and writing in the same fashion, and that helps, right? It reduces the potential for one lone wolf to be the only person that can maintain that, right? Make sure that everyone is working in the same sandbox. You share your toys. Infrastructure scales much, much better when you're working in a monolithic code base. Right? We have a dedicated compiler team. They are the best. Right? If we had a separate code base and a separate, for every individual project, a separate code base for Drive and for search and for ads and for news and for all of the things, right? Some of the larger teams might have one or two dedicated people on we're gonna take care of the compilers, but it doesn't scale well, right? Once you get everyone in the same place, infrastructure scales, right? Compilers and common libraries, right? All of those things. There's good scaling properties. As someone on an infrastructure team, one of the great upsides to a monolithic code base is that we get usage visibility, right? When I want to change a common API, I have visibility into literally every place where that API is called. So it is a doable and, because we have practiced, fairly tractable task to introduce a new, better API, change all of the callers of the old thing, and delete the old one. And this is a task that can be done in days or weeks instead of months and years if you're deprecating things with a traditional release cycle. But there are downsides to this monolithic idea as well, right? I've talked with people at the conference here about, our organization is getting bigger, we've got 50 or 100 people, and just syncing our Git repository is now taking too long, right? It is a meaningful overhead, right? When we bring in new hires, the amount of history that is coming along in our repository, just you have to tell them when they show up on day one, start your repo sync, let's go to coffee and fill out your papers, all that stuff, because it's going to take a little while, right? Things like scaling will get worse. This type of scaling will get worse if you don't dedicate resources to solving those problems, right? By consolidating, you also give yourself bigger problems. It's just that by consolidating, it makes more sense to assign people to fix those problems, right? So there's a trade-off there. The biggest con to a monolithic code base, in my opinion, is that you cannot just throw it away and start clean. So we'll look at I'll explain that. This is kind of hypothetical, very simplified monolithic code base. We have some utility code, we have common RPC. Because we're in a monolithic code base, everyone can use the common things. This helps, this is nice. And as you start to grow and you realize, we need to add, a common authorization system to our services, there's a common place, an easy single point, choke point, to add that. This is nice. But as you start growing, you start adding more and more edges to this graph. This graph is always just going to be more and more complicated, and sometimes even stop being a strict DAG. Your builds get weird, things get complicated. Once you start having this graph, there is no way that you can say, oh no, everything is gone to hell. We have to throw it away and start over. Because you cannot take the good parts with you. The good parts are dependent on the bad, and the bad are dependent on the good, right? It just becomes a hairball. I don't believe that there is any principled way to grow to this scale and really avoid this problem and keep the ability to panic. A per project culture means that you get the big red button option. A monolithic culture means you have to get this right. And that brings us back to lifespan, right? Over the duration that your code base is going to live, right? You may, very expensively, push the panic button on a per project repo, but you will never be able to push the panic button on a sufficiently large monolith. And so that's my thoughts on lifespan. Why do I care about lifespan? Care about lifespan for your projects because change is inevitable. This is not surprising, right? If you were to ask anyone, like, is it safe to assume that we're never going to have to change any of the things we depend upon? No one is going to say yes to that. It's just that usually we are very concerned with getting to the next release in 2 weeks, right? Getting through the next QA cycle this quarter, right? And we lose track of this bigger picture of, at some point, yeah, we're gonna have to update our compilers, right? We want the new language features. Or even if you don't want the new language features, you want the new compiler because it fixes that miscompilation error that keeps triggering those random bugs, right? Yes, compilers have bugs, right? If you are fighting with the completely mysterious, there does come a point where you have to mistrust the compiler. Tooling changes. You have to be prepared for that at some point. Bugs will happen, right? Who's heard of Heartbleed? Who had a system that had some vulnerability to that? Who actually worked and made sure that it got fixed? I hope those are the same hands, right? Bugs are going to happen, right? Even if you attempt to never change anything, at some point we are going to have bugs like Heartbleed, right? You cannot pretend that everything you depend upon is completely static for all time. Not if you want to be a safe, responsible citizen of the information technology world, right? You're going to have to be able to at least patch OpenSSL, if not update OpenSSL and all of the libraries that it depends upon, right? And then you're changing a significant amount of your web serving code, right? Your change is inevitable. And new attacks will emerge, right? I'm going to talk a bit, frame all of this a bit in terms of things like hash flooding. Hash flooding is terrifying, right? Who's familiar with hash flooding? Not too much. Interesting. So hash flooding is the notion that your hash containers, your unordered maps, your unordered sets, these are supposed to give you order 1 lookup, right? This is what's advertised, right? What if your attacker knows that you are storing some part of your query in an unordered map? They know that when they issue a query to your service, it is going temporarily or for a while into an unordered map that is keyed on a string that they passed in, right? You say, oh, I need to do map storage for these things. I'm going to take the name of the person in this request and use that to keep track of state about this request, right? You're using unordered map. Odds are pretty good you're using standard hash. How hard do you think it is to find collisions, that is 2 inputs that hash to the same thing, with standard hash on any input on any string, right? This is purely a matter of just burn some CPU, right? Standard hash is not a cryptographic hash. It is not intended to protect you against that. So if they can calculate a whole bunch of inputs that all hash the same thing, they can feed all of those inputs to your system, and then your order 1 lookup becomes order n lookup. As they flood you with this, your nice, quick, I just need to go check this thing in my hash map becomes an order n operation, and your service crawls to a halt. This is an attack on your data structures. If you are not terrified right now, you need to go get more coffee and come back, right? Because you're not paying attention, right? If you cannot even trust the things like your data structures in perpetuity, right? You have to be prepared for change, right? You cannot assume a completely static infrastructure in the long term. And I have weaseled a little bit. You will notice usually appearing on this slide in a couple places. Right? There are maybe exceptions. I would say if you're working in government contracts, I think there are some domains where it is probably not the best plan, but actually maybe legally mandated that nothing is ever going to change. In which case, this is probably not the talk for you, because I am very concerned with change. So if a change is necessary in the lifespan of your project, do you have a plan to tackle it? That is it possible to make a change of that sort? And, maybe more interesting, do you have practice in making those sorts of changes? And now this actually gets me to, I think, provide a working definition for sustainability. Your organization's codebase is sustainable when you are able to change all of the things that you ought to change safely and can do so for the lifetime of your codebase. Whether you choose to do so is your business. Right? I am not saying that everything that goes wrong needs to be fixed. You totally have the option to note that this is a problem and choose to consciously take on that technical debt, those risks, that annoyance, that long-term maintenance hassle. And if you do that with open eyes, I have no problem with that. I am not saying that your code base is unsustainable. What I am saying is, if you do not have the ability to fix whatever problems are going to come up over the lifespan of your code base, then you have an issue. That make sense? So, in my experience, to be sustainable, you will need some or all of testing if you're reacting to something, if you're making a change, how do you know that this change is safe? You will very likely need policies. Right? You will need policies to guide your engineers, to guide release processes, to guide all sorts of things, because engineering is not a purely technical activity. Right? It is also a social enterprise. Right? We are people communicating with each other and working out how to, make progress as efficiently as possible. Right? You will need some policies. There will definitely be technology that you will want to rely upon. And then you will need to practice. Okay? So I'm going to kind of motivate. We'll just start with the notion, okay, so you have a problem, you need to change how your hashing works. We'll start there. For example, I argue that you need testing. Right? You need a culture of testing. You may have been to my talk on testing earlier in the week. I really think that this is important. Okay? We were talking at lunch a couple days ago. Someone was pointing out, 10, 15 years ago, it was not completely rare to encounter engineering groups, or so-called engineering groups, that were still kind of shaky on, yeah, you should be using version control, right? Right? If you think back a decade or two, you may have worked for one, right? A decade ago, the place I worked for, we were using version control. It was very good. But some of the contractors that we were working with did not, and we had to get in big fights with them about, no, guys, grow up. You're going to do this. I think these days it is pretty clear, yeah, you're an engineering company, you're going to have version control, right? Does anyone disagree? Is that not your experience? Right? Version control, clearly, right? Marshall?
I run into small companies occasionally.
Yeah, there are small companies, but at this point, culturally, you run into small companies that don't, and you're like, really? Really? Right? It's not well, yeah, I guess I see your point. It's really? Right? I think testing is going to be the same thing, right? I think it's going to take us probably another 10 years before we get to the point that it's really? You're not testing? I think we're on the forefront of this. It's better over here. Trust me. Not least of which is because tests are your first line of defense when change is coming, right? Tests are your first line of defense for enforcing the contracts of your code and the code that you depend upon, right? You being told you need to write tests is not necessarily about, I don't think your code is correct, I don't think you're good at coding, right? That is not what tests are implying. Tests are, if you like, implying the team that your code relies upon sometimes makes mistakes. Make sure that the way that your code functions with those dependencies in place is working properly. It's only polite for the people above you. And you get to exert some pressure on making sure the people below you, who aren't to be trusted, are doing the right thing, right? If you want to phrase it that way, to like make it feel like this isn't, we're watching you, we don't trust you, think of it this way, right? This is, I think, more palatable for some people. And when you have tests everywhere for the whole code base, it is much easier to tell, like, okay, I made this change. Did the world explode? No. Does that prove the change is safe? No. It's at most kind of an existence, like, yeah, this is not provably unsafe. Right? And it's not quite the same. The kind of web of trust by verification that you get from having tests everywhere is not a proof that the code base is working correctly. It is, at most, good evidence, kind of statistical evidence that you didn't destroy everything. But it's the best we got. I've said this in a couple places now, I will say it again. If you do not currently have a testing culture, and you need to get there, you're going to have to hold this line at some point. No more changes go in without a test. And no bugs can be marked as fixed without a test that demonstrates the bug and demonstrates that it's fixed. Right? The right way to do that is to write a test that demonstrates the bug and then come up with the fix so that it's nice and quick to check to see if your fix was right. Right? It makes all of this debugging engineering stuff much, much easier. Right? At some point, you have to hold this line. I will admit that if you have a large, messy code base with no tests right now, you will probably have a month or two where it feels like your velocity has been slowed. It's a finite amount of time, I promise. And in the long term, you will be much better off. I have heard of 0 instances of groups that had tests as a part of their culture and said, we're stopping the testing requirements so that we can sprint to this release. And that succeeded. In all cases, you drop velocity. In all reported cases, you drop velocity when you stop testing, and you increase velocity when you start testing. Okay? Any variance in that is at most a short-term difference. You will also, if you have tons of tests, that's a good first step, but you will also need test infrastructure. Right? If it's hard to run your tests, nobody will do it, and if no one is running the tests, then they're not doing any good, and no one's going to write tests. So, compare. This is pretty much what testing was like at my previous job. It's like, I think that this package that I'm trying to make a change to had tests. Some other group wrote it. Where are the tests? I'll go check the README. Oh, those require me to install something. Oh, but that other group has a different OS, so I need to install different packages. Oh, there's a version mismatch. You burn a couple days on it. This is not the most fun you've ever had. Then you finally get to run the test. The test doesn't pass. Now you're not sure if it's because you made some changes before you started running the tests or if your installation was wrong. This is no fun, right? You can easily burn time on this. It's terrible. This is roughly how testing works for us, and this is roughly what you should aim for. Right? Your tests are built into the build system. The same thing that you use to run the test or to make the build can run the tests. Right? We open sourced Bazel. It is effectively a very small difference between the open source Bazel and what we use internally, and this makes life much, much easier. Right? No one has to figure out how to build the test, where the test lives, any of those things. You just spin it up. It's the same in every project. Very, Very, very much an important thing. Because your tests have to be quick, reliable, and consistent across the organization. Right? If an infrastructure team needs to make a change to something that everyone relies upon, it does not scale for them to have to learn 100 different ways that tests get run and projects get built. Right? Does that make sense? And you're going to need policies. My favorite policy on testing is what we call the Beyoncé rule, which is, if you liked it, you should have put a test on it. I'm not joking. It is official policy that if we make a change to core libraries, to core infrastructure, to the compiler, to anything, and your project breaks, like you start shipping on-fire software to your customers as a result of this change, if you didn't have a test, it is not our fault. We will not roll it back. We are not responsible for you shirking your grown-up duties of, like, yeah, you're going to have a test for that, right? Not our fault, right? Beyoncé rule. It's a big fan. And that's kind of one of many sorts of things that I think you need as policies for how to guide the code base, right? That one is very particular to testing, and in general, there's a lot of kind of policy and guidance sorts of things that you can do to kind of encourage people to be moving in the right direction. All right? You need ways to guide the code base. This is more important and more easier to do in a monolithic code base. I am a big fan of the monolithic paradigm. So going back to the hash question, what if everyone wrote their own hashes? Right? What if everyone wrote their own hashers? And what if everyone wrote their own containers, like unordered containers, right? There's no way for you to fix and defend against hash flooding if everyone's got like spun up their own stuff, right? Without having reuse and consistency, the problem is intractable, right? There's no way that you're going to be able to track down all of the various implementations and all of the various containers and all of the things to make the same fix and test in all of these different places, right? You want consistency. And so one of the things that I find very valuable in encouraging consistency is a style guide. I gave a talk on style guides last year. I don't particularly care about the formatting stuff in a style guide. Pick one and move on. Better yet, like, pick one, encode it in Clang format, and move on. Right? There are far more important things to use up your brain on than how many spaces to indent or whether to use tabs. Don't care. Argue about something important. Style guides are far more valuable for things like, no, in our code base, because it's difficult to gather all of the threads and have a reliable shutdown sequence, it is super important that you do not have namespace scoped variables with complex destructors, for instance, because one thread is doing destruction of global variables and other threads continue like churning along, right? This means that at shutdown, which is a very difficult time to debug things, one thread can be accessing a string that's already been destructed or a complex object that's already been destructed. And when you start accessing things that have already been destructed, you're off in undefined behavior land, right? And this can be arbitrarily bad, right? You can have horrible data persisted to your database, right? Impossible to track down, impossible to duplicate bugs. A style guide is a good place to prevent, like to say, no, do not have complex globals. A style guide should be kind of interpreted almost with the force of law, right? If you choose to violate those things, you should be doing so with eyes open. And that's part of why in my talk last year, I was hammering on the rules in the style guide should both serve a purpose, and that purpose should be made clear. Right? If someone knows why the rule is there, then they can make an eyes-open engineering decision that that doesn't apply, or that's a lesser risk than what I'm fighting against right now. Right? But generally, style guides should be kind of nearly law. You also need code review. I said earlier, probably the number one important thing for making your code base survivable is testing. And the number two thing is code review. Code review and take it seriously. Right? Programming is freaking hard. Anyone want to disagree with that? I would actually argue that all of the interesting software engineering is, by definition, about the hardest thing that we can do. And I'll say why. The issue is everything that is less complex, like not on the bleeding difficult edge of we're about to fail to complexity, everything that's safely back here, this is easy. There's probably existing solutions for this. This has been solved. Right? There are open source solutions and there are solutions, just all over the place. Trip over, easy problem solved. Right at the boundary, this is where the interesting work is happening, because anything further out here, we can't solve. Right? Software engineering is the act of balancing on this edge, and software engineering practices are everything that we do to help you lean further out. Code review helps you lean further out in a big, big way, right? Because software engineering is hard. If it wasn't hard, we would be doing something else. Since software engineering is hard, it makes sense to have more than one pair of eyes on it. And this is not it makes sense to have more than one pair of eyes on it because I'm only a junior programmer. This is straight up, it makes sense to have more than one pair of eyes on it. I regularly do code reviews for some of the very best programmers in existence. And it is never the case that on a meaningful chunk of functional change, there isn't something that I catch. It could be we could get slightly better performance if you did this. Or, that looks like a copy instead of a move. Or, often, this needs to be documented better. I know mostly what you're doing, and 6 months from now when we have to change this code again, I don't want to have to refigure this out. Comment that, right? Code review, if code review works for and is valuable for the very, very, very best programmers in the world, it's valuable for you too, right? Take it seriously, please. In addition to the style guides, the force of law, we have also found that there is some need for guidance. On average, you really probably want to avoid doing this, but it's stuff that it's a much lower bar. I would draw the following comparison. We get a lot of additional warnings and things added to our tool chains. Right? We add more warnings to Clang, and then make those into errors so that the build fails. But you can only do that if you are 100% certain that that is always an error. Or, in the unlikely event it isn't an error, there's an easy way to disambiguate it to the compiler, right? For example, if foo equals 5 instead of if foo equals 5, right? You meant equals equals. The compiler tells you that these days. If you really meant single equals, if you really meant assignment, it says in the compiler message, just add an extra set of parens there. Then I'll trust that that's what you meant, right? Same thing here, right? The style guide is the things like the compiler, and then we have best practices, which is things like that are not quite as cut and dry. Okay? One of the things that I cite a lot in our best practices series is things like use our string view equivalent in APIs that are accepting strings. Unless you're trying to store it yourself, then take that string by value. Or things like Don't use G flags, our library, our flag library. Don't define flags in the middle of library code. Define flags in main, because flags are globals, and it's just not good engineering practice to have all of your library behavior dependent on globals. These sorts of things you don't want like enforced by law, but they're good advice. One of the things we do is we have a process called readability. Readability started long, long ago. The first non-owner employee of the company, employee ID number 3, made it his job, whenever a new hire came on board, he wanted to explain how Google works. This obviously didn't scale after some point, and so some volunteers kind of joined the effort. Like, okay, we want to make sure that you know how Google works. This is back in the days when Google was one thing. Right? This made a lot of sense. What they were really doing was providing mentorship. Right? We need to explain to you, this is where the utility code goes. This is where the library code goes. This is how the style guide works. These are where the tools live. Right? We need you not to rebuild all of those things just because you're new here. We need you to know like how our stuff works. Right? And then once you've demonstrated that you know that, then we say, okay, now we trust you. The way that we do this is every change that is sent out for review, in addition to having to be code reviewed by someone, has to be someone that has readability in that language. It's kind of a badge. Someone that has readability in that language needs to sign off on it. If it's the original author of the change, that's fine. If it's the primary reviewer on the change, also fine. If neither of those people actually has the readability badge for C++, they need to get a C++ reviewer to go like check, nope, that is not how you use const. Or nope, you are dangling memory there. Right? You need a language person to check through things. Right? I don't know that you have to have something like that, but I strongly suggest you come up with some way to mentor and onboard your new hires. Right? And the more heavily you invest in that mentorship, the better your outcomes are going to be, in my opinion. Because that, like, the point where you've just hired them is the point where you have the best ability to bring them into consistency with how you want the organization to run. Right? And then you may, I don't know, these are definitely in order of importance. You may want to have some sort of churn policy. We added a rule at one point, that still we obey, that the infrastructure teams are not allowed to change things and push the work of reacting to that change off onto everyone else just willy-nilly, right? If they're changing things, they should do the work of moving you from system A to system B. And you may also want something about just making textual changes across the whole code base, depending on if you're worried about people making silly changes at scale. We occasionally have to tell people, no, I don't care if you go fix all of the British spellings of gray. It's not a good use of our time. You'll also want technology. Clearly, we're engineers, we like technology. Where do you invest for long-term sustainability? You're gonna probably want distributed build and test. Right? You probably have some sort of distributed build system if you're starting to scale up. I would strongly encourage that you consider using the same distributed build system to distribute running of your tests as well. Right? Because, like I said earlier, if it takes like 2 hours for your developers to run the tests and make sure that everything's okay, that reduces their development cycle usefulness quite a bit. If you can distribute that, if you can make the tests run nice and quick, right, they're going to be much happier. They're going to run the tests more. Your code base will work better. For consistency, you probably want to pick a common test framework. I like gtest. There are many. Find one. Be consistent. Don't let every team make individual changes to it and tweak their own copy. Like, use one, make it common, make it consistent. Tests ought to be built into the build graph, as I kind of alluded to, but your tests should live right alongside the code, should live in the same directory as the code that they're testing, and should be easy for everyone to run in a common sort of way. Then you get into things like, how do you actually generate a change at scale? For hashing, this is not really an issue, right? We're going to go into the standard library. We're going to go into our hash utilities. We're going to go into a couple like known places, and we're going to make very targeted changes there. But there are other types of changes where you need to update the text of the code base. We had a talk on this last year. My colleague Hiram talked about how we use ClangMR and some other tools to generate the textual change and figure out how to test and get the massive change submitted. ClangMR, we could give a whole talk we probably have on ClangMR, but very briefly, this is Clang MapReduce, and we are using the Clang internals, like take the abstract syntax tree after the code has been parsed, and apply pattern matching to the syntax tree to find every place where a call is being made to this particular function with a parameter of this sort of type. Right? You can express arbitrarily complicated things in there. It's far, far, far more powerful than regular expressions, obviously. And then once you have identified a piece of code like that, generate an actual edit for that call. Then it's just a matter of checking in all of those 10,000 edits. Other things that are going to be very useful for the maintainers of your code base are things for code base understanding. I really, really like that we have an indexer. This is a new concept as far as I'm aware. We have open sourced the indexer. I recommend that you maybe figure out how to spin it up and index your code, because you will find surprising new uses for this. The indexer idea is C++, like you cannot run search for get to find all of the places where a get method is called on your class foo. But you can ask the indexer, hey, index, I have class foo. Tell me everywhere that .get for that class is called. Right? This is based on, we did a build last night of the whole code base. Right? And just remember everything about the AST from the previous evening. Right? Find me every file where that exact function on that exact class is being called. And this will peer through macros and templates and all sorts of things, right, to get you exactly the set of things that you need. It's very handy for maintainers. You probably also need a proper regular expression search and things like that. I recommend investing there. And you definitely need tooling for bug reduction, because the easiest way to not have to make a giant change is to prevent those problems from happening in the first place. Right? You want a good, healthy code base. Run continuous tests. Run continuous tests with the sanitizers turned on. I am also a big fan of static annotations. We use static annotations for thread safety. This is available in Clang and older GCCs. I think we stopped maintaining it in GCC. And the idea is basically this. We're going to have some class. We can say, there is data in this class. That data is guarded by this lock. Right? Nice and simple. And then I will also say, you cannot call the function update with that lock held. Just by saying guarded by lock, it is now a compilation error if you touch data in a code path that doesn't have the lock held. You can also prevent deadlocks, and it also enhances the analysis understanding of the control flow. If you tag things as, you cannot call this function with the lock held, and you must call this function with the lock held. This is thread safety enforced by the compiler. Every time that I inherit a package, kind of an orphaned package in our codebase that has any threading behavior, the very first thing I do is go annotate just the simple parts, run the build. Build always fails. There are always bugs. Right? This is super easy, high value. Raise your hand when you spot the bug. Couple hands starting to go up. There we go. 10 seconds for the quick ones. Couple hands still haven't gone up. Clearly, the bug is there is a path out of here where the lock is not released. You should probably fix this by having RAI like on your locks. But not everyone does. This, by virtue of just having annotated the mutex class, the compiler now knows, oh, unless I specifically said otherwise in this function, every path out of this function better have the same characteristics on the lock. Specifically, I took it, I need to release it on every path. Those are great. They don't catch everything, but they certainly catch a lot. We can do more complicated static analysis with things like Clang Tidy. See also Tricorder. There's been talks about that in the last couple of years. Tricorder is our general purpose language agnostic platform for plugging in static analysis tools and having the results of those static analysis tools surfaced in our code review tool, which is exactly the point, well, which is the latest point in the development workflow that you really want that information surfaced. It'd be nice if you had that in your editor as you were going, but sometimes the static analysis is a little too expensive for those things. So at least trigger it so that it's there, surfaced at code review time. Clang Tidy in particular is automatic compiler-based code understanding looking for particular anti-patterns. So you could have something like this. Who sees it? Couple, yeah. Clang Tidy sees it. And this is not particularly revolutionary, but it's nice because the compilers are better at spotting this than the humans, right? This is an easy, quick win, right? You can stop worrying about stuff like this and just offload to the compiler, focus in code review on the higher level things like, is this documented properly? Is this a sensible design? Are you solving the right problem? Compilers not as good at that sort of thing. And then this is kind of the most important part of all of this. You can have practices in place, you can have technology in place to try to prevent problems from coming in, but you're gonna, when it comes down to it, if it is a crisis, if you have to update your hash, if you have to update your compiler, if you have to update OpenSSL and rebuild and deploy and all of those things, do you have practice in actually doing that? Right? Because it's one thing to know in theory that you can make a change, and it is quite another thing to know that you can actually get it pushed. Right? It turns out that fixing, like doing low-level code-based maintenance, doing cross-cutting, broad textual updates to the code, making changes to core libraries, all of those things are a skill, like anything else. It is a sub-skill of the greater thing of being a software engineer, right? But they are a skill, and all skills get better with practice. Right? You will need practice. You will need some sort of insight into, like, how is this all going to work? Like, off the top of your head, can anyone estimate what is the largest number of files that you could, in your code base, submit in one change? You might want to know that. You might also want to know why not to do that. Like, if you submit a change of that maximum sort of size, will you be able to roll it back? Will you be able to roll it back 2 weeks from now? Without practice, you will not know the answers to these questions, and I cannot tell you the answers to these questions because it clearly depends on your code base and your organization, right? You'll need to figure out how to do those things on your own. And you certainly don't want to do that while the thing is on fire. I will revisit. You're going to need testing, right? You cannot know that something is safe without tests. It is not sufficient, but it is necessary. You will need policies to mitigate the crazy, because I guarantee that the one guy on that team that sits off in his own little corner and has built a whole domain-specific language is making trouble for your code base. Guarantee it, right? You need to have some policies to rein that stuff in. You need technology. Technology can help avoid the necessity of reacting in a panic. And you need practice. You need practice. You really, really, really need practice. You cannot do this live the first time. Over a long enough period, change is inevitable. Think about how long your code base is going to be with you and decide if you are prepared for a scary one, if you are prepared for the big one in that period. If the set of important changes that you know you ought to get to is only growing, you are eventually going to fail. Right? If you cannot chip away at the list of, yeah, we should get to that, eventually the technical debt is going to overwhelm you on a long enough time horizon. Right? You might have 10 years before it starts to matter. I hope you do. Good luck. But eventually these things add up. There are definitely problems that were introduced in our code base almost 10 years ago that we are just now getting around to properly solving. And unfortunately, there are complicated reasons why they went from a low-level annoyance to, yeah, if we don't solve that in 2 years, it is going to be a significant organizational problem. Now we have a timeline. We cannot fix it leisurely. We have to go do it now. I wish that we had planned slightly better. Technology, coding standards, policies, more technology will make it possible to make changes safely. And practice makes perfect. Okay? Good luck.
Hello? Okay. I have a question, or maybe try to get your thoughts on it. You said something earlier about how 10 years ago, not a lot of startups or even small companies use source control, but was that a consequence of it being more difficult to set up source control at that time, and now it's very easy because we have great tools and things that help us out? So is that why that changed? And is testing getting that way where people don't do testing because it's difficult to do, and are we getting better at testing?
I don't know that there's a definite yes or no to that. I would argue that source control 10 years ago, we still had Subversion. That was fine. It wasn't so bad. It's certainly better than RCS. If you go back to RCS, then yeah, I can understand that you might not want your organization to pay that cost for source control. Yeah, I think some of it was advancement in technology, and I think a lot of it is the far simpler thing of, as an industry, we've gathered enough war stories and battle wounds to realize, no, you have to do that. I suspect the same is happening in testing. I hope.
Sorry. Do you have any suggestions for convincing coworkers and/or management that testing and fast builds are a good idea?
Yell?
That's what I thought.
No, there's more. You should make the case, if it's not, clear by inspection that something would have been caught earlier, start keeping a log, right? Keep your secret log of, yeah, we shipped this bug. That bug was pretty clear that we could have caught it by a unit test. We shipped this bug. Pretty clear that that would have been caught by a unit test. We shipped this bug. Integration test would have been better for that, right? And if you come to them with probably, 3 months, maybe 6 months worth of log on that, right? Estimate took us 2 weeks to debug this, right? It takes a day, tops, to write a decent unit test. Tops, right? Most of the time it's more like hours, right? That's a pure financial sort of trade-off, right? I think the hard part is a little bit of that. I certainly have met management that was unconvinced that tests were adding to the bottom line, but I don't think it's a super hard case to make. The thing that I think is usually harder is the engineers who don't like feeling like you're saying that they're not good at their job, right? And it's not about that. It's not about proving in the moment that your code was correct. It is about proving forevermore that the code stays correct. Because change is coming, right? And without some sort of proof that the code stayed correct in the face of change. But it's hard. We're gonna have to share stories of how we convinced our organizations to test next year.
Here. Hi. Thanks for the talk. Could you share any best practices in how to handle ABI stability, or do you simply not care because you use a monolithic big thing with everything, so you could even change the SDL?
Did you say ABI or API?
Well, both, right? It's kind of related. If you change the ABI, you need to recompile everything, and that takes a long time.
Yeah. In a monolithic code base, you worry a lot less about that. ABI compatibility, you definitely do have to worry about because we have third-party vendor code from time to time. There are bits that just have to be precompiled. You can't break that. So you will have, your tooling teams will have to worry about things like ABI compatibility. For API compatibility, having knowledge of how your code is being used is the big win, right? We have a monolithic code base, everyone builds from head. The indexer is just indexing at head. Clang MapReduce runs basically at head, right? So I don't have to worry too much about API incompatibilities when I'm making a change because I can see where it's likely to break. If I run it through all the tests, I can see where the build broke or where the tests broke, and then quickly make an edit to everybody to change them to the new thing. I have hope that going forward, this will become practical for domains that aren't monolithic by virtue of, here's the API that you're depending on. I changed it in this release. Here's a tool that updates you to use the new thing. Because this is totally practical. We just have to get to the point that we trust that sort of tooling. Other?
In a world where we build software for a lot of different platforms, we need to have build tools that are able to handle all that. You suggest that we use Bazel, but Bazel doesn't support Windows, which is a pretty important platform. So do you have any recommendation on how to manage all those tools in a big code base where you have to build Windows, Mac, iOS, Android, and everything, and everyone wants to use their own tool?
We have some of those problems because we do ship code for Windows and we do ship code for iOS and Mac and Android and those things. There's the monolithic part of the code base, and then there's the little bits of the code base that fall into those cracks. And mostly we're working through that right now kind of by groping blindly. We actually just talk more. We find the teams that have those sort of requirements and we ask, what tool chains are you using? What platform are you actually building for? How can we get those sorts of things automated into our system, either by VMs or whatever? so that we can get them back into they'll be kind of a weird case, but we can get them back into, as large as possible, the mainstream sort of development standard. And the other part of that that's really important is once we know what tools they're using, we have to also enforce minimum requirements, right? Like, I will not allow you to use a Windows compiler from 10 years ago because that's holding back our ability to use more modern language features, usually in the code that needs it most, usually in the utility code, right? And that's really unfortunate, right? So getting a sense of like, what are all the things you're using, and then starting with just asserting minimum standards and best practices and trying to push those forward, that starts to help. We're going through some of the same. I expect that there will be work in this area.
Hi, I have a question about code reviews. More so in the area of quality of them. Mm-hmm. We instituted a policy where every check-in requires a colleague to code review. Mm-hmm. If you look at code reviews of the same code, one might say looks great. The other might have a page worth of things that they see wrong. Mm-hmm. Did you experience any of that, and how do you and how did you go about fixing that? You do absolutely experience that. We do certainly have some of that. There are certainly teams that take it less seriously than they probably should. One thing is, even if you send the change to 2 different reviewers and get 2 completely different answers, that isn't enough to prove that there's a problem. Right? One person may say, that is functionally correct, and you wrote some of those things in a style differently than I would have, but I don't care. Whereas the page of review notes may be, just all nits about, well, I would have named this something else. And we actually eventually got to the point of we had to have policies on when it's okay for a code reviewer to be putting down their foot and when it's not, right? Like, you can request that you make those sort of ancillary changes, but if it's not actually important, don't fight and die on that bridge, right? The other thing, in readability, actually is a big one. I'm working on making that much more clearly a mentoring process, and I have kind of a pilot program running of a slightly new, more long-form mentoring. And one thing that I'm doing is lurking a lot of the code reviewers and sending them comments about, oh, you said this, that's actually not what I would recommend, or you said this, here's a nice citation for that in the style guide. Because it's much more valuable for people when you say, this is wrong. It's much more valuable to say, don't do this because, and it's very nice when you say, don't do this because, and here's a citation. Right? And so teaching the mentors to be better mentors scales very nicely. So that's one of the things I'm working on.
So you gave an example earlier of a 10-year-old piece of code that has now become critical that you need to change, and you want to do it in the next kind of 2 years.
That would never happen.
Well, it happens to us all the time. I mean, we have a very similar kind of legacy code base, which is of similar size. I guess, have you developed any strategies for influencing or, I guess, relating to management the importance of investing in core infrastructure and modules so that we get the correct amount of people on it? For, let's say, a company that doesn't have infinite resources?
I cannot express how much of a failure I have been on this point.
So, high fives all around?
We've had some success in the tooling stuff, especially because those are nice, easy things to kind of quantify. Mm-hmm. Like when you look at, here's a graph of build times, that is going in a bad direction. Then they're willing to throw some effort at compilation times and things like that. When it's a matter of, hey guys, these APIs are bad and everyone's complaining, they're like, I don't know how to prioritize that versus dollars or traffic or QPS or whatever.
And so it is the hardest part of my role by far, is figuring out compelling ways to make the case that, nope, still got to do this. Nope, this task is not going away. Nope, as we scale up, we need more support, not less. So please, someone come tell me how to convince management. I will buy you dinner.
Thanks.
So the testing is essential part of development process, and sometimes you face with the problem that the full code base testing overcomes the overnight period of execution, how you solve this problem. So if you push something in a base code, you need to pass through a lot of coverage. So it may require a lot of time, and sometimes it's more than a day. How you all solve this kind of situation?
You'll note that I specifically said, like, work on distributed build and test environment, because it is not going to work to just have every developer running the tests locally, right? Your tests are going to scale with the number of hours of effort that a SWE has put into the code base total, right? And we're looking at 30 SWE millennia in C++ or something like that. Software engineer millennia. Right? No one is going to be able to run sequentially, even on all the cores on their very nice desktops, all of the tests. Clearly, you have to have distributed test environments. So that's a minimum first step. As to it still takes a while, yeah, it still takes a while. We've learned to, we are always working on probably 6 or 7 different things, because you just have to wait until it's done cooking. And you also have to learn when to trust that this is safe enough and just move ahead. So.
All right, last question.
Last question.
Just harking back to the previous question, the one before last. One of the things I've noticed over a long period of time relates to the role of leadership in arranging for the kinds of things that you're talking about to actually happen. And you alluded to some difficulties in getting some of those to happen. And I wondered whether you had any thoughts about encouraging and nurturing and ensuring that such leadership, and I mean the qualities of a leader to make these things happen, are actually present in the organization, or whether it's just really the luck of the draw.
I think the hard part is that for a lot of these things, unless your engineering leadership has been very forward-thinking, it is going to be unclear who is responsible or authorized or anything to take a given step. Right? As you scale up, it becomes easier for everyone to look around and be like, "It's not my problem." And in the worst case, everyone looks around and says, "I don't have the authority to solve this." And if that's the case, if everyone looks around and "I don't think I have the authority to approach this problem," then your organization is doomed, right? And so one of the things that has been in Google's DNA very early on is the phrase "act like an owner," which is assume that you have that power. It is, in many cases, especially for things like making organizational shifts and kind of policy shifts, it is far better to pretend like you have that power and just do it and see if anyone says no, than to let everything go bad. And you're not necessarily going to make all the friends by doing that, but you'd be surprised, I think, in practice that works pretty well. So anyway, thank you all very much for your time.
Thank you.